mock-up one of the radio listening stations that were dotted around the coastline,
Right.
rather than being at Bletchley. And these things in the middle, the brass things, are what's called the undulator.
Right.
And that basically listens to the waveform
Yeah.
of the teleprinter, and it writes it down on this piece of tape.
Right.
And then, if you know what you're looking for, you can work out the characters for each of
Yes.
these, and they were then translated back into perforated tape. So this is the message being translated back into perforated tape.
Right.
This is what was taken to Bletchley Park.
Right. Okay, that makes sense. Yeah. Okay.
And then on this side, this is is what I was talking about earlier on, where Bill Tupp, this chap here, was writing out the code in columns to look for patterns.
Ah, that's what I saw on the board. It had like a big, massive board. Okay.
And so that message I mentioned, the message that was sent twice, that was the kind of source material.
Yes.
And this is where he comes up with the logical operation of the machine.
Right.
So what you have is you've got the 5 bits of data coming in here. They pass through the first set of wheels, which encrypts them.
Ah, okay.
They then pass through a second set of wheels, which encrypts them again.
Okay.
And then the output is what you get out of the machine.
Right.
Every time you send a new character in, these wheels will move on by one position. And you can see they're all different sizes. So it gets out of sync with one another as they move.
Right.
And then the second set of wheels moves about half the time, and the half the time is determined by these 2 wheels. They're called the motor wheels.
Right.
And that was designed to improve the code itself and increase the encryption security.
Okay, I didn't know they had like 2 sets of wheels.
Okay. It's a double encryption.
Ah, right, okay.
What the code breakers realised was because these wheels move about half the time, it's almost exactly 50%.
Right.
If you look at the difference between one character and the next,
Yes.
if these wheels haven't moved,
Right.
then they effectively don't exist, and all you're looking at is one set of wheels.
Right.
So they're breaking they're basically breaking the problem down into smaller and smaller chunks.
Yeah.
So with this block diagram,
Yes.
the post office engineers were brought in, and they put together this machine in the middle, which is known as the Tunny machine.
Right.
And what that is an electronic or electrical interpretation of the mechanical machine.
Right.
So that machine, although it looks completely different,
Yes.
it's electrical rather than mechanical,
Yes.
is an exact emulator.
Right, so it's running emulation simulations.
So if you have your settings for this machine
off the Lorenz.
you could use a real Lorenz machine,
Okay.
send a message that was then decrypted by the Tunny machine,
Right, okay.
which is exactly what they used it for.
Awesome. Tunny machine, okay.
And then this machine on the right hand side, this is the Heath Robinson
Right.
that I mentioned. So here you've got the 2 tapes which are being compared.
Yes.
And as the machine goes round, one tape is one character shorter than the other.
Yes.
So every time the tape goes round, it gets one character out of step.
Right.
And there's a little tiny thing you can just see on the left hand side, just above the green and yellow switches.
Yes.
There's like a little counter.
Ah, right, okay.
The operator would have to read that counter number and the output of the counter
Yes.
every time the tape went round, and write it down. And then that information would then be used to work out the useful settings.
Right.
Whereas if you remember on Colossus,
Yes.
that's all being done for you automatically. You just got to run the tape and it'll print out the interesting answers.
Right. So how often, like on a day-to-day basis, would they get interesting answers? Were they hacking daily, I guess, from their superiors?
So they're running multiple messages during the day.
Yes.
They may or may not get the interesting answers out.
Right.
But typically, especially on Colossus,
Yes.
the tape run would be about half an hour to run the full thing.
Right.
If they didn't get an interesting answer out, they would go on to the next message.
Right.
They would potentially come back to that message later if
Yes.
they had time.
Yes.
But this is all about getting through as much as you possibly can. So,
Right.
So checking every message for half an hour is
Yes.
more efficient than checking a message and then continuing to
Mm-hmm.
because the thing is, you don't know you've got your guess right,
Yes.
so you might be creating garbage.
Yeah.
So it's better to move on to the next one.
Right. Okay. All strikes me is like how they, what's the word? Obviously, you know how efficiently they were operating, but were kind of documenting their progress. So, because they were documenting their progress, they were never. It doesn't seem to me that they would ever get frustrated. So that frustration would get to move to the side, and then
sort of pragmatism.
Yeah.
I think the figures are around about. I think it's less than 10% of all the messages that
Yes.
were intercepted. So first
Yes.
you've got to intercept the message,
right.
and then you've got to actually work on it. Get it intercepted, get it here, and then work on it. So I think it's less than 10%
Right.
of all the messages that were intercepted were actually decoded in a timely manner.
Yes.
So you're still, you're looking at a portion of the messages only.
Yes.
It's not like it's a complete
Yes.
open book and you're reading everything.
Yes.
But that 10% is
Yes.
still enough to give you that advantage that Senator.
Yeah. It's so the word I was thinking about is So for instance, how so they were able to deal. Well, it's not frustration the right word, but like the abstraction, like involved, like and how they were able to, let's say, like get to different kind of milestones, right? Like in that approach, which is really inspiring, 100%.
But also, even though this machine was not
Yes.
as reliable as it could have,
Yes.
as it could have been, it certainly wasn't as fast as using a Colossus machine.
Yes.
They still built numbers of them and continued to use them. So the Heath Robinson machines
Right.
and the Colossus machines were being used
Yeah.
at the same time.
Yes.
Because again, it's all about getting as much traffic through the process as you possibly can.
Right.
Because you're not going to get every message read.
Right.
So the more you can check, the more likelihood you are to get something.
Right. Okay. So what's this machine here in the middle? Is that a?
So that's a that's a sort of teleprinter
Okay.
sheet.
Yes.
So it's linked to the Tunny machine.
Okay.
In the same way that this teleprinter machine
Yes.
is linked to the Lorenz. So you would either you would type your message on the teleprinter machine,
Yes.
either live into the machine to get
Yes.
your output, or you could print it out onto tape so that you could feed it in later. And this is the thing I mentioned as well, the board that sets up the initial settings.
Right.
So
Okay.
it's this board that you then use to set the position on the rotors.
Yes.
And you can also see on the rotors the little switches.
Yes.
And that's where you're setting the zeros and ones. Now, typically that cover would have been closed.
Yes.
And only a ranking officer would have been able to open
wow.
up and change the switches.
Okay.
They only change the switches infrequently, so about once a month or so.
Yes. Yeah.
But the operator would have been able to move the wheels to the positions as they needed to. Towards the end of the war, they started changing more frequently as they
Yes.
became more and more concerned that the codes were being broken. So they,
Right.
they were changing the settings more frequently. But by then it was too late. We'd already got a break in.
Yes.
And we were able to adapt.
Right.
There was a newer version of the Lorenz machine that
Yes.
was kind of in the works.
Yes.
That effectively removed this statistical flaw that we've been talking about
Sure.
attacking. Had those machines gone into operation, it's likely that the window would have been closed and you wouldn't have been able to see any traffic anymore. Similar to what happened when the German Navy changed their operations on Enigma in I think 1941, and there was a period where they couldn't break any codes because they changed the procedure and
Yes.
all of the existing techniques didn't work.
Right.
But I think this updated machine would have been a little bit less open to be broken into.
Right. Okay. Awesome.